Welcome to Maths and Science channel. In this lecture for Maths Olympiad, some good example about algebra is brought, wherein we have to find x and y if 37 to the power of x plus y has last two digits as 9 and 7. The last two digits are 9 and 7, and 37 to the power of x plus y. This is the value, and it has last two digits as 9 and 7, and we have to find out x and y. This particular problem involves not only basic modular arithmetics, it involves Lagrange theorem, Carmichael theorem, Lagrange theorem, modular arithmetics, then modulo, Euler theorem, and also gives insight on congruence and modulo. These are the 6 or 7 topics we'll be taking up while solving this problem. The problem is find x and y if 37 to the power of x plus y has last two digits as 9 and 7. This is the problem. Let us try to solve it. What is the equation given here? 37 to the power of x plus y has 9 and 7 as last two digits. We have to find x and y. How much? One by one, let's go. Let us try to solve it. A simple method to solve is, because we have to find the last two digits, from the Euler theorem, we can find out (37) to the power of some z 1 modulo 100. Because two digits means we have to find out (37 to the power of z 1 modulo 100 equivalent to). Here 1 is the remainder, and it is the number we have with us, and it is the divisor. Which implies in simple mathematics we can write 37 to the power of z minus 1 is equal to m into 100. When you divide 37 to the power of z with 100, there should be a remainder of 1. That is the Euler theorem. If it happens, then What will be the value of z? If it is true, if above equation is true, that implies z is equal to phi of 100. This is the Euler theorem. How to find out phi of 100? Phi of 100 is equal to how much? It implies here 100 is equal to how much? 100 is equal to 4 into 25. That is equal to 2 square into 5 square. The powers are same. Bases are here 2 and 5. 2 square into 5 square. That implies 500 as per Euler theorem. It is 100 into 1 minus 1 by 2 into 1 minus 1 by 5. That means this 2 is written here and this 5 is written here. 500 is equal to 100 into 1 by 2 into 4 by 5. That is equal to 40. That means 37 to the power of 40 is equal to 1 equivalent to 1 modulo 100. From Euler theorem, the first answer or the first step what we have done is that 37 to the power of 40 equivalent to 1 modulo 100. This is the first equation we have got. Now, we have to find out, are there any other repeating equations like this? For less than 37 to the power of 40, for less than power 40, are there any repetitions are there, the same equation, or are there any repetitions more than 40 power? Let us try to find now. Now, here we will be using the Carmichael function. Next is Carmichael function. What Carmichael function says? What it says? As per Carmichael function, some number some prime a to the power of m equivalent to 1 modulo n. This is a Carmichael function. Why to use it here? How to use it here? Let us see now. These concepts are very, very important. Provided GCD of an is equal to 1. Now, what we have got here? Hundred is equal to 2 square into 5 square. Carmichael function for this combination lambda 100 is equal to LCM of lambda 4 and lambda 25. Lambda 4 here is lambda 4 is equal to 2. How we have got 2? Here, you see, a to the power of m. Here, a square is equal to 1 modulo 1 mod 4. What is a square? That is 2 square. Lambda 4 is nothing but 4 is equal to 2 square. Hence, lambda 4 is equal to 2. Now, second, what is the value of m such that 2 to the power of m equivalent to modular 25, because here it is 25, here it is 4. 100 is equal to 4 into 25, whereas Carmichael function says a to the power of m equal to 1 modulo n. By using this, for example, lambda 4 is equal to 2, since 4 is equal to, for this lambda 4, for this it is lambda 25, 4 is equal to 2 square, which implies m is equal to 2. That implies 2 square is equal to 1 modulo n, or 1 modulo 4. What is n? This is n. Please try to understand. This is one answer. Now, lambda 25 is equal to 20. How we have got here? How we have got this answer? 20. I will show you now. Here, n is equal to 25. A to the power of m is not known. A is equal to 2. 2 to the power of m is not known. Because m is not known, which we have to find out. This m is equal to, in case of 25, this is equal to m in case of lambda 4 is equal to m in case of 4. 2 to the power of m is equal to how much? We don't know. N is equal to 25. But as per Carmichael theorem, 2 to the power of m 1 modulo 25. That implies 2 to the power of m minus 1 is equal to some constant into 25. When 2 to the power of m minus 1 is divided by 25, there should be a remainder of 1. Remainder is equal to 1 when 2 to the power of m is divided by 25. Now let us try to write all the values of 2 to the power of 1 by 1. What is 2 to the power of 1 is equal to 2. It cannot be divided by 25 and gives a remainder of 1. No. 2 to the power of 2 is equal to 4. It cannot be divided by 25. 2 to the power of 3 is equal to 8. It cannot be divided by 25. 2 to the power of 4 is equal to 16. It cannot be divided by 25 and give the remainder. 2 to the power of 5 is equal to 32. Remainder is equal to 7 when divided by 25. 2 to the power of 6 is equal to 64. When it is divided by 25, it gives a remainder of 14. We want a remainder of 1. Please remember, as per Carmichael function, 2 to the power of 7 is equal to 128. Remainder is equal to 3 when divided by 25. 2 to the power of 8 is equal to 256. It gives a remainder of 6. It is also not correct. 2 to the power of 9 is equal to 512. It gives a remainder of 12. It is also not required. 2 to the power of 10 is equal to 1024. It gives a remainder of 24. That is also not required. Like this, when we go on doing it, 2 to the power of 20 gives a remainder of its value is 1048576 and it gives a remainder of 1 when divided by 25. That means the minimum value, the minimum exponent required for this equation to satisfy, that is 2 to the power of m 1 modulo 25 implies m is equal to 20. We can even do it very simply. From congruences also we can do. We have calculated 2 to the power of 10 is equal to 1024. That means 2 to the power of 10 plus 1 is equal to 1024 plus 1, that is 1025 divisible by 25. That implies 2 to the power of 10 equivalent to minus 1. If you take one other side, minus 1 modulo 25. When we square on both sides, we need not do 2 to the power of 11, 12, 13 like that. To the extent possible we will do, and afterwards we will square. 2 to the power of 10 when we square, 2 to the power of 20 equivalent to minus 1 whole square mod 25. That implies 2 to the power of 20 is equal to 1 modulo 25. From 2 to the power of 10 directly we got the value of 2 to the power of 2 to the power of 10 we got the value of 2 to the power of 20. Then this is equal to, therefore lambda 25 is equal to 20. Lambda 4 is equal to 2. And LCM of 20 and 2 is equal to 20. That means the minimum exponent required for modulo to repeat itself is 20. That means for every 37 to the power of 20, this implies for every 37 to the power of 20, there will be cyclic repetition. (37 to the power of x plus y can be written as 37 to the power of 20k plus some b. X plus y value is not a single value. Why we have found out this Carmichael equation, and also we have used this other congruence principles to find out whether there is a behavior of repetition of the value. Here in the question it is asked to find the value of x and y. They have not put any limit. That means x plus y can have any value. It can range from one particular minimum value to infinity. And we have to find out the general value. For that reason, the general value, to find out the general value, we have to use the Carmichael function. And now the first, in principle, the first value, the first requirement for finding the x plus y will be, x plus y will be in the form of 20k plus b. Because it is multiples of 20, it is getting repeated. This is getting repeated. This is the initial x plus y. B is the initial x plus y and general x plus y. General x plus y, y is equal to 20k plus initial x plus y. Now, let us find out at the initial value. At which initial value? 37 to the power of x plus y is equivalent to 97 modulo 100. This is what we have to find out. We have to solve. This is the equation. I will repeat it here again. What we have to find? To find 37 to the power of x plus y whose last two digits are 9 and 7. Because we are considering two digits, we have to ensure that 30, it can be written as x plus y equivalent to 97. Remainder should be 97 when it is divided by 100. Mod 100 means divided by 100. When this particular item on the left hand side is divided by 100, then it should give a remainder of 97. Because last two digits are, this is the remainder. Last two digits are the remainder. Now, we have to find, let us say x plus y is equal to b, let us say. Then 37 to the power of b equivalent to 97 remainder when divided by 100. When you start talking like this, when you start repeating this like this, you won't forget the definition of mod 100. 100 is used for 2 digits, 100, and if it is 3 digits are asked or given, then it should be 1000. 4 digits means 10,000. Modulo 10,000. Here 2 digits we have asked, we are using modulo 100. Mod 100. 37 to the power of b is equal to 97 is the remainder of mod 100. That means when 37 to the power of b is divided by 100, then it should give a remainder of 97. That is the problem. Then we have to find out the value of b. Now, let us start. Let b is equal to 1. What happens? When 37, the value will be 37 to the power of 1 is equal to 37. When it is divided by 100, what will be the remainder? Remainder is equal to 37. When b is equal to 2, this value multiplied by 37. Because we are considering only two digits. It may have more digits. Afterwards, we are considering only the last two digits. This implies remainder is equal to 69. What is the remainder we have to get? Remainder we have to get is 97. This is the remainder. When I divide with 100. When b is equal to 3, when b is equal to 3, 37, I need not take all the 1369, I can take only 2 digits, last 2 digits of the previous value. 37 square into 37, what is 37 square? That is 1369, I need not take because I am considering only 2 digits. What I have to do here? 37 square means 37 into 69. What is its value? It is 2553, which we can do without calculator very easily. Remainder is 53. When b is equal to 4, what are the last 2 digits? 53 here. 37 to the power of 4, that is equal to 37 into 37 cube, that is equal to 37 into 53. 37 cube, whole number we don't require, we only require 2 digits because we are only considering 2 digits. Then 37 into 53, that will be 1961. Last, we are only calculating last digits, last 2 digits. R is equal to 61. Now, when b is equal to 5, 37 to the power of 5 is equal to 37 into 37 to the power of 4. 37 to the power of 4, already we have got 61 as the remainder. That means 37 into 61, last 2 digits. That is equal to 2257. What is the remainder when divided by 100? remainder is equal to 57. When b is equal to 6, 37 to the power of 6 is equal to 37 into 37 to the power of 5, that is equal to 37 into last two digits are 57, that is equal to 2109, and remainder is equal to 09. When b is equal to 7, 37 to the power of 7, that is 37 into 37 to the power of 6, that is equal to 37 into 09, that is equal to 333, r is equal to 33. When b is equal to 8, 37 to the power of 8 is equal to 37 into 37 to the power of 7 is equal to 37 into 33, that is equal to 1221. Last two digits only we are taking. Remainder into 37 to the power of 9 is equal to 37 into 37 to the power of 8 is equal to 37 into remainder of 8 is 21, that is equal to 777. Remainder is equal to 77. b is equal to 10. 37 to the power of 10 is equal to 37 into 37 to the power of 9 is equal to 37 into 77 is equal to 2849. Remainder is equal to 49. b is equal to 11. 37 to the power of 11 is equal to 37 into 37 to the power of 10 is equal to 37 into 49 is equal to 1813. Remainder is equal to 13. b is equal to 12. 37 to the power of 12 is equal to 37 to the power of 12 is equal to 37 into 37 to the power of 11 is equal to 37 into 13, that is equal to 481. Remainder is equal to 81. b is equal to 13. 37 to the power of 13 is equal to 13 into 37 to the power of 12 is equal to 37 into 81 is equal to 2997. Here you see the remainder has come as 97. That means b is equal to 97. Our answer has come. Now b is equal to 13 and remainder is equal to 97. And k is equal to 20, we have already got. That means x plus y is equal to not k is equal to 20, it is some value. K is k, proportionate. 20k plus 30. Hence, x and y will follow the equation 20k plus 13 means x plus y initially can be 13, x plus y next will be 20 into 1 plus 13, that is 33. Then x plus y can be, it is first value, this is the second value, this is the third value, 20 into 2 plus 13, that is 53. That means the value of x and y vary as per this equation. That means ultimate answer is x plus y is equal to 20k plus 13, or we can even write in the form of mod as x plus y equivalent to 13 is the remainder. When divided by 20. This can be like this. The final answer is this. This is written as this way. Either this x plus y is equal to 20k plus 13, or x plus y is equivalent to 13 mod 20. Both are same, both are correct. Now here we have to find out the value of x and y separately. We have got the value of x plus y. Now from x plus y, if x plus y is equal to 13, we can have any combination of x and y. What are the combinations? Pairs we can write. We can write the pairs as x plus y is equal to 13. The pair of xy is equal to 0, 13, 1, 12. The values of x and y can vary 0. If k is equal to 0, x plus y is equal to 13, then we can have a combination. If we want positive integers, for k is equal to 0, what are the combinations? The pairs will be, range will be 1 and 12 for positive integers. For x, y, positive integers. If x, y, if we want in positive as positive integers, we can have the values as pairs as 1, 12, 2, 11, 3, 10, 4, 9, then 5, 8, 6, 7, 6 and 7, then 7, 6 and go on up to 12 and 1. That means the final answer is x is equal to 1, y is equal to 12. Final answers. X is equal to 2, y is equal to 11. X is equal to 3, y is equal to 10. X is equal to 4, y is equal to 9. X is equal to 3, y is equal to 10. X is equal to 2, y is equal to 11. X is equal to 1, y is equal to 12. Similarly, we can have combinations. X is equal to 1, 2, 3, 4. Instead, what we can write here? 1, 2, 3, 4. 5, 6, 7. Not this. X is equal to 5, x is equal to 6, x is equal to 7. X is equal to 5, y is equal to 8, x is equal to 6, y is equal to 7, x is equal to 7, y is equal to 6, then x is equal to 8, y is equal to 5, x is equal to 9, y is equal to 4, x is equal to 10, y is equal to 3, x is equal to 11, y is equal to 2, x is equal to 12, y is equal to 1. And these are the final values, final answers, x and y we got. Can we plot them? Plot. What happens? X plus y is equal to 13. That graph we have to take. Let us try to plot it. What is there? For positive integers. Because ultimately geometrical representation is also required. X is equal to 1, y is equal to 12, let us say here. X is equal to 2, y is equal to 11, let us say here. X is equal to 3, y is equal to 10, x is equal to 4, y is equal to 9, x is equal to 6, y is equal to 7, x is equal to 7, y is equal to 6, x is equal to 8, y is equal to 5. That means it is a straight line. I have shown only for your information. This straight line will be like this. This is x plus y is equal to 30. This is the graph. This is the plot of this particular equation for which we have got different values. This is for k is equal to 0. Then we can put k is equal to 1 and get all the x values, y values. Then we can put k is equal to 2. Then we can put k is equal to 3. And this is for k is equal to 0. X plus y is equal to 13. The final equation is x plus y is equal to 20k plus x naught y naught, where x naught y naught is for what you call, this is for x naught plus y naught. X naught y naught is for initial value k is equal to 0. Let us see. X plus y, general x plus y is equal to 20k, k ranges from 1 to any number, plus x naught plus y naught for k is equal to 0. This is the general equation we will give, and you can try the plotting of for various values of k. Now with this I want to conclude this session. Here I have discussed about Carmichael function, Euler theorem, modular arithmetics, modulo, positive integers and congruence. Equivalent is nothing but congruence. And with this I want to conclude this session, and please view my other 4 videos also from my channel Maths and Science. My channel is Maths and Science. I want to bring forth many videos of this type to ease the concepts of algebra for Maths Olympiad and JEE IIT Advanced courses. Best of luck, farewell. Thank you for listening to me and thank you for viewing my lecture. Thanks a lot. Thank you. Please subscribe to my channel Maths and Science for regular updates. Thank you.